Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Okay, this video is about evaluating an improper integral with an infinite bound. Alright, so basically an improper integral with an infinite bound is any integral that has infinity in it, whether it be like negative infinity to a certain number or, like in this problem, a certain number to infinity. So when you evaluate an improper integral either from infinity or to infinity, you're either going to get like an actual number when the graph ends up hugging the curve, or it's going to like never like approach the curve and it'll just be infinity. So with this one, 1 to infinity of 2 over x dx, this is the graph and you can see it ends up hugging the curve. So you're actually going to get like a numerical answer for this one. And then on the other hand, when you have 1 to infinity of x squared dx, I mean, you know the graph of x squared, and when you keep plugging in larger numbers for x squared, it just gets exponentially larger. So as you can see in the graph, it's just, you're not going to get an answer, it's going to be infinity. Right, so actually evaluating like the integral with infinity, it's the same as evaluating any other integral. So for multiple choice, you don't even have to worry about any of the notation stuff. But for FRQ, since it's considered an improper integral, you have to put limit as b approaches infinity, because you can't like actually integrate from to infinity or from infinity. So see here, you just put limit as b approaches infinity of 1 to b of f of x. And then it could also be like negative infinity to 1. And then you just put limit as b approaches negative infinity from b to 1 of f of x dx. So you only have to worry about this on the FRQs, because multiple choice is just whether you get the right answer or not. And honestly, for multiple choice, if you're writing limit, it's probably kind of wasting time and might probably more prone to mistakes. But for FRQ, whenever there's a problem where you're integrating an improper integral with an infinite bound, there's always a point for correct limit notation, so putting the limit in front. It's the easiest point to get, like it's not even anything math related, but a lot of people forget it, so just try to remember to put the limit in front whenever you have infinity. Okay, so now we're going to do a multiple choice question. It says, for what value of k is the integral from 0 to infinity of kx e to the negative 2x dx equal to 1? So remember, since this is a multiple choice question, we don't have to worry about like putting the limit in front or anything. You can just evaluate it like you would any other integral. So this really, it's just a normal integration. So first thing we're going to do is put the k out front, since k is a constant. And then you're left with k 0 to infinity of x e to the negative 2x dx equals 1. So if you just like run through your integration methods, u substitution doesn't work, and so this is going to be a by parts. And then if you remember for by parts, the order is Liate, so x is algebraic, which is the a, and then e to the negative 2x is exponential e. So your u is going to be x, and then your dv is e to the negative 2x. And then when you derivate x, it's 1, and then the integral of e to the negative 2x is negative 1/2 e to the negative 2x. And then you do the k is still up front, and then you have uv, so x times negative 1/2 e to the negative 2x minus the integral of v du. So since it's minus negative 1/2, it switches to positive, and then I put the 1/2 out front since it's easier to integrate. And then you have the left side stays the same, and then on the right, the integral of e to the negative 2x we already did for the dv in the prior part. It's negative 1/2 e to the negative 2x. So that leaves you with, on the right side, negative 1/4 e to the negative 2x. And then you have that whole section is going from 0 to infinity. So you just plug in the infinities. And so I put you have -1/2 infinity e to the negative infinity, and it's a little bit easier to picture if you put e to the negative infinity on the bottom. So I did that for the left side, and then you have that part minus when you plug in the zeros, and then that's on the right side. So that on the left side you have negative infinity over 2 to e to the infinity, and since e to the infinity grows faster than just infinity, it's going to go to 0, and then same with the 1 over 4 e to the infinity, that's also going to go to 0. And on the right side, since you multiply by 0, that whole part goes to 0, and then you have -1/4 times e to the 0, and e to the 0 is just 1, so it leaves you with the -1/4. So it's kind of a messy problem, but it's not too difficult. So then it leaves you with k times 0 minus 0 minus 0 minus 1/4. So it's really just k times -1/4, which is just k times +1/4. And then that whole thing, you have to set it equal to 1 from the problem. So you just multiply 4 over, and you get k equals 4. And then that was C. All right, so now on to the free response question. This free response question was part of the Calculus BC test in 2017. So if you want to look up like the full problem, since we're only going to do a part of it, or look up the scoring guidelines or whatever, you can do that. So it says let f be the function defined by f of x equals 3 over 2x squared minus 7x plus 5. And then it says use the identity that equals 2 over 2x minus 5 minus 1 over x minus 1. And it wants you to evaluate 5 to infinity of f of x or show that the integral diverges. So really, this is just a simple integration part of the problem. But since this is an FRQ and they actually grade your work, you have to remember to put the limit in front. So limit as b approaches infinity from 5 to b of f of x dx. So you start with 5 to infinity f of x dx, and then you put the limit in front. And so f of x from up top equals 3 over 2x squared minus 7x plus 5. And then since they gave you that equals 2 over 2x minus 5 minus 1 over x minus 1, you're just going to plug that in. So there you go. And then now for this part, this is kind of the result when you do partial fraction decomposition. And if you remember from that, you always get natural log because you get u substitution. So like on the left side, the u would equal 2x minus 5, and then du is 2 dx. So you just have 1 over u du, and that's just natural log. And then on the right side, same thing. It's u equals x minus 1, and then du is 1, so you don't have to worry about a fraction correction or anything. So remember, keep the limit as b approaches infinity in front. And then you have natural log of 2x minus 5 minus natural log of x minus 1 from 5 to b. And then if you remember with logs of the same base, so like natural log is just log base e, it's the same base. When you add, you can multiply the interior parts, and then when you subtract, you can divide them. So you see here, we just put natural log of 2x minus 5 all over x minus 1. And then now you plug in the b and the 5, so still have the limit in front as b approaches infinity, and then you have natural log 2b minus 5 over b minus 1, minus the natural log when you plug 5 in, so 2 times 5 is 10 minus 5, you get 5 on top, and then 5 minus 1 is 4 on the bottom. And then now you can actually plug in the infinity since you have limit as b approaches infinity, and since when you plug in infinity, you just worry about the highest like factor for like your x, or in this case b. So you have 2b over b, and then when you just plug infinity, like 2 infinity over infinity, it's 2. So you have natural log 2 minus natural log of 5 over 4. And this is the same thing. When you have natural logs and you're subtracting, you can just divide. So 2 all over 5 over 4. And then that's going to give you with natural log of 8 over 5. All right, and so this is the like the scoring guideline part for this part of the problem. This was part C of problem 5. Is worth 3 points. So you can see one of the points was for the limit expression, and like the problem was only worth 3 points. So like you can mess up the problem or something, but as long as you put the limit in front, you guaranteed 1 point. And then 1 point for the antiderivative, which is basically all our work, and then 1 point for getting the correct answer. So I mean, honestly, the easiest part is just putting the limit in front as b approaches infinity of 5 to b. Like you don't have to do any math for that, but it's the easy part to get. So just remember when you are evaluating improper integrals with an infinite bound, multiple choice, just do it how you normally would. Like you don't have to worry about the limit or anything since you're just like bubbling in an answer sheet. But when you do an FRQ and you're showing your work, you have to put the limit in front.